Hello everyone, myself Nishitha, Assistant Professor, Department of CSIT, working at Amala Institute of Technology. In previous session, we have seen about input-output hardware applications and what are the different types of operations performed by input-output hardware. So in this session, we are going to see about streams and performance. So overview of this presentation, we are going to see about streams and performance in operating system. So what I mean by stream processing? It is a technique of data processing and management. So it is going to process some data and managing, which uses a continuous data stream and analyzes, transforms, filter or enhance in real time. So whatever the data which is processed and managed, it can be used continuously. That can be analyzed and it can be transformed and it can be filtered out. So this is how the streaming is done in the operating system. Once processed, the data is sent to an application. They can store the data or another stream processing engine. So it can store the data or it can retrieve the data or it can transfer the data in a specific order. Stream processing engines enable timely decision making. It is a timely decision making and provide insights of data flows in, making them crucial for modern data-driven applications. So it is a data-driven application and it is maintaining some crucial for each modern to flow of data. It also known as several names including real-time analytics, streaming analytics, complex event processing, real-time streaming, analytics and event processing. So it consists of several names including real-time analytics, streaming analytics, complex event processing and real-time streaming analytics and event processing. These are the different kind of names provided by the stream process. All the various terminologies have previously different tools, nothing but frameworks, have coverage under the term of stream processing. So these all are considered under the stream processing. So here, whatever you are sending the data, so you are transferring some data. I am sending some data information. So here the stream engineering processing the data and giving us output in the output screen. So here writing the code, I am writing the code A plus B in C language. So then it is stream and it processes and gives the output screen in the monitor as file. So this is how the stream is performing input-output operation, giving the data and it is processing in the stream process engineering and we are displaying the output in the output screen. Nothing but performing the stream in an input-output operation based on the stream processing engine. So in the stream processing, we are having data collection, data injection, real-time processing, data transformation, immediate insights, instant actions and what is the output. So data collection is nothing but data is continuously collected from various resources, nothing but like sensors, social media or any financial transactions. So these all are collected in the form of sensors, social media or any data collections, nothing but financial transactions. So whatever your transactions amounts will be under in the data collection. Next, data injection. The incoming data is injected to the stream processing engine without waiting to accumulate large batches. So it cannot accumulate large batches and it is transforming in the form of who are under the waiting list. Real-time processing. Each piece of data is immediately analyzed and processed when it is arriving. So whenever the data is analyzed, then the process is arriving. That is how the real-time processing is occurred. Data transformation. The engine may transform the data such as filtering, aggregating or enriching it with additional information. So it is providing some information by filtering, aggregation, or enriching with the additional features of this information. That is how the data is transformed to this data transformation. Next, immediate insights. The processed data provides real-time insights and results. So it is providing some real-time insights and results. Instant actions. Based on the insights, the system can trigger instant actions or responses, ensuring timely decision making. So based on different kinds of things, they can trigger the actions and whatever the response coming, and ensure the time which you are going to make on the decisions. That is what instant actions. Next, output. The results are outputted to various destinations such as dashboards, databases, or alert systems for further use of analysis. So what is the output? You are performing some code, then you are going to get the output of that code, and all these are used by these dashboards, datasets, and all their systems for different kinds of analysis. Next, there are several factors that can impact the performance of computer system. Nothing but it can produce some processor speed, memory, storage, input-output devices, and software optimization. So what do you mean by processor speed? Here the speed of the processor measured in the form of gigabytes. So here it is measured in the format of gigahertz. Determines how quickly the computer can execute each and every instruction and how they can perform the process each and every data. That is how the processor speed is done in the stream's performance. Memory. The amount and speed of the memory, including random access memory and cache memory, can impact how quickly data can be accessed and processed by the computer. So whatever you are sending and receiving, how fastly it is occurring and how fastly we are acknowledging the message from the server side. So this is what accessible in an higher way, means very quickly you are accessing through some memory accessibles. Storage. The speed and capacity of the storage devices, including hard drives and solid state drives. So it is having some hard drives and solid disk drives, can impact the speed at which data can be stored and retrieved. So it can be stored or it can be retrieved back. So next, input-output devices. The speed and efficiency of input-output devices are nothing but keyboard, mic, and displays. Can impact the overall performance of the system. So it may increase the input and speed and efficiency of input-output devices that may be under the devices such as keyboard, mic, and displays. So this improves the performance of the system. Next, what do you mean by software optimization? The efficiency of the software running on the system, including operating system and application, can impact how quickly tasks can be completed. So how the task is completed. Based on the software, you can complete its task. Next, computers performance, and what do you mean by response time and throughput, and next CPU execution time. It is the amount of work accomplished by a computer system. The word performance in computer performance means it basically depends on the response time, throughput, execution of the computer system. So here the performance of the computer system is acknowledged by each and every moment. So here that each and every moments are nothing but it is taking some response time, throughput time, and execution of the computer system. So how much time is required to complete its execution, how much time it is taking to respond to each and every process, what do you mean by it of each and every process. So what do you mean by response time of each and every process? So response time, it is the time from the start of completion of a task. It also includes operating system overhead, waiting for input, output, and other processes, accessing disk and memory, time spent executing on the CPU or execution time. So what are the response times means operating system is getting overhead there. and it is waiting for input, output and any other processes accessing the disk and memory, and it is taking some time to spend its execution on the CPU, or it is known as execution time. Throughput, it is the total amount of work done in a given time. So it is when the process completes its execution and the total amount of that execution it is done by the given time. Next, what I mean by CPU execution time? It is the total time of CPU spent on computing on a given task. So it is performing the amount of time which is performed to complete its task by its given time. It also excludes time for input, output or running other programs. So it is also excluding its time to complete its running of the programs. This is also referred to as simply CPU time. Performance is determined by execution time, as performance is inversely proportional to execution time. So here the performance is determined, execution time is inversely proportional to the execution time. So it is inversely proportional. So in this session we have discussed about streams and performance. So what do you mean by stream and how it is going to perform the input output operation? So we have seen. If you have any doubts, you can comment in comment box. Thank you.